5,413 divided by 16. Again, another reminder is that we can represent division as a fraction, which is basically this. We can also represent it as a division problem using a divided by sign, or we can use this way to represent it, which is what lots of people call the standard algorithm. So now we need to ask ourselves, will 16 go into 5? No. Will it go into 54? Yes. Now 16 is not too far from 20, which is easy to estimate with. 2 20s would be 40, 3 20s would be 60. So 3 might be a good guess since 16 is less than 20, so let's try 3. 3 times 6 is 18, 1 times 3 is 3, plus 1 is 4. So 48 does work. So we're going to put 3 there and a 48 right here. After we divide in division, we subtract. So we need to borrow, and 14 minus 8 is 6. 4 minus 4 is 0. After we subtract, we bring down. Now we have 48 as 16 times 3. We could try 16 times 4 and see what that gives us. 24, 4, 5, 6. Too high. So why don't we stick to the 3, and now we have 48 here, and we subtract. 11 minus 8 is 3, 5 minus 4 is 1, and we bring down the 3. Alright, so now what are we thinking we can do to get 16 into 133? 64 plus 64 is 128. That sounds to me like that might be pretty close. So what if we doubled this? What if we double that and get an 8? So let's go 16 times 8, see what we get. 6 times 8 is 48. 1 times 8 is 8. 9, 10, 11, 12. We have 128. Can't go any higher than that. So let's go ahead and put an 8 right here and find out what our remainder is. Should have left more room. 13 minus 8 is 5. So it looks like we have a remainder of 5. Now, how can we check that answer? Yeah, it's a little difficult to check. Maybe we could pull up a calculator and use that. I'm just curious because we ended up having a remainder. So let's try checking this once. Let's go 338, multiply it times 16 and see what we get. Well, we get 5,408. Now if we take that 5,408 and we add the remainder to it, so let's add 5 to it, let's see what we get. We get 5,413. So I like the answer. We end up with 338 with a remainder of 5.